Good morning, students. Today we're going to be looking at orthographic projection in a lot more detail. So this chapter is available in your textbook from page 27 onwards. So it's important that you go and read through all the instructions and you go and do the exercises and work through the examples as well. So this is an example that shows you how to draw in third angle projection and also how to do first angle projection. There are some examples, some exercises. So you might be asking yourself, what is first and what is third angle projection? Well, before we get to that, let me just explain a few things about orthographic projection. So if we just sketch a quick isometric view here of a block or a cube, all right? So this is some random cube. We can also draw the hidden detail over there of the cube. And we count the number of sides. Let's say this is the front, so that's 1, that's 2, that's 3, the top, the bottom, that could be 4. And then this side could be 5, and that one is 6. So you can see there are 6 sides on a cube. Now this means that when we approach an orthographic projection drawing, we've got 6 possible views that we can draw. Because an orthographic projection is essentially taking a 3D object as you see it there, looking at it from one perspective, which we call a point of view, and drawing what you see. So if we had to look at this block from that side and draw it on a flat piece of paper as a 2-dimensional drawing, we would see a rectangle. Sorry, not a rectangle, it is actually a square. So this would be from the point of view, whatever that point of view is. So that is what we would see. And the reason we only see that front edge, we're actually seeing only this edge over here, is because these sides are parallel. So this face, that face, and the top and the bottom are all parallel to the point of view. So they're moving off away from us directly in line with your point of view. The back surface doesn't have any distinguishing features on it, so there's nothing there to actually draw. And the back edge is in line with the front edge, so that would just be drawn over the top of it. So essentially you just end up with one line going all the way around. Now, strictly speaking, in real life, a person's eyeball is looking at something. If we look at a block, we're actually looking from a point, and we're looking in a converging plane like that. So this edge is actually, although it is parallel, it's actually not in line with our point of view. So there's the eye looking at it, and that is, this is what we call a perspective. Perspective view. Now, perspective view is what we actually see in real life. Now, just to simplify things, orthographic projection does not take into consideration perspective view. Orthographic projection assumes that all of that you're looking at it with projection lines that are all parallel to the surface. So there is no diverging of your lines. Just for interest's sake, talking about perspective view, if we had to draw an object in perspective view, let's take this block for example. There's many ways to do it. There's a single point perspective and there's 2-point perspective. So let's just take 2-point perspective. Let's say those are the 2 points, which we call converging points. So we would then draw lines from those converging points, and we would draw our block. So vertical lines would all be parallel to one another. The top of the block would be like this, and the back, that up there, and that point would join up over there. So this would be, we'll just make that a little bit darker. This would be a what we call perspective view of a block or a cube. And that is drawn as a 2-point perspective. Now you can see the difference between isometric and perspective. In perspective view, your sides are not parallel, and that is more in line with what we would see in real life, because as I said, we have our eye is a single point and we're looking at things far away, and the further away they get, the smaller they are. So if you're looking at a railway line, the railway line would start wide and it would move away from you like that into the distance, standing at one point and looking down the railway line. So that is also perspective. All right, so just so that you understand, when we're talking about orthographic projection, we are not drawing a perspective view. So we're not doing exactly what we see. We draw it as though it is all our lines at our viewpoint is all parallel to the plane that we're looking at. All right, so all of our lines, our viewpoints are now parallel to the surface, so we don't see the back edge of the block. All right, so moving on from there, orthographic projection was developed as a method probably by architects many hundreds of years ago, to draw buildings for construction and various things that were manufactured in those days, just to make it easier to actually convert that design into something that can be built by the people doing the building. And the reason it's so helpful is that we're drawing the scaled actual size of things. So if we're drawing perspective view, you can see these lengths, they're the same length. This length is the same as that length in the block. This is a block with equal sides. But none of the sides are their true length. They're all at different angles and at all different sizes. Even though in real life, if you measure that block, it's all the same. All those lengths are the same. So if this block is, for example, 100 millimeters, let's just put some dimensions on it, by 100, we can see that in an orthographic projection, we can draw the true scaled size of that object, and that then is very useful when you want to see how things are going to fit together, how they look in real life, what the actual scaled size is, and to design some things that are complicated. So that's a very useful way to do it. All right, so just to explain things a bit more clearly, I'm going to be using this camera case. So this is a camera case for a GoPro, quite an old one, so here are two. So as you can see, it is sort of rectangular. It has a depth, tapers towards the front. It has an aperture here for the camera to look through. It has a few buttons, etc. Now let's look at orthographic projection views. If we had to draw an orthographic view of this, we can decide how we're going to lay out our drawings on the page. And some of you in school might have come across this idea that you have your views and then you have a diagonal line, and then you can transfer some of the dimensions across from the front. Let's say that's the top and that is the left. So some of you might have actually had some experience in this and some of you might not, but this is essentially a way to decide how you're going to place your views on the page in your orthographic projection. And when we draw a front view, for example, we start with the front view. That's kind of the origin of the drawing, is we start with the front view and then we lay the views around it. We decide which ones we want to put around it. So if we want to draw a top view, for example, there's two places we can draw it. We can draw the top view on the top of the object, on the same side that we're looking from, or we can draw it on the bottom, below it, the same top view. We can draw it on the top or we can draw it on the bottom. The left view, if we're looking at it from the left, we can draw that left view on the left, what we're seeing there, we're looking like this, or we can draw it on the right hand side. And that choice, it has to be consistent, and you have to tell people interpreting your drawing which way you have chosen to draw it. And the difference between those two interpretations is called first angle projection or third angle projection. So we've got first angle and third angle projection. Hope you can read my handwriting. Now, in first angle projection, this is the standard that South Africa uses, and Europe and most of the world. America uses third angle, so this would be America, and this would be SA. So we need to know how to draw in first angle projection, and if we're designing something, we will stick to that system. But we need to understand that if it says it's third angle projection, then we need to know how to interpret it. The difference between them, as I've just explained, is the positioning of the views. Now, in first angle projection, which we draw in, we draw what we see on the opposite side of the object. So the left, we're looking from the left at this surface of the block, and we draw what we see on the right hand side, and we call it the left view. We're looking at this block from the top, and we are seeing that surface. We're drawing what we see below the block as a top view. So this would be first angle. Projection. All right. So first angle projection, you're drawing what you see on the opposite side. Third angle projection, you're drawing what you see. If you're drawing from the left hand side, you're seeing that surface, and you're drawing the left view on the left. You're drawing the top view on the top, the bottom view on the bottom, the right view on the right. That would be third angle projection. Each of those has a symbol. For first angle projection, we would draw that symbol. As you can see, it's a cone. We're looking at the cone from the left and we're drawing it on the right. And third angle projection, you would just switch them around and do that. And you will have come across the symbol already in the earlier chapters of this course. So those are the symbols for first angle and third angle projection. So in this view, we're looking at the left view from the left. We're seeing that circle there and that circle there, and we're drawing it on the left hand side. So therefore we're drawing it on the same side. Another way of thinking about this is to look at a 3D object. So let's take my camera case here. In first angle projection, I would draw what I see on the opposite side. So let's say I'm holding it up and I'm looking from the top downwards. In the case of this video, but it's essentially, if I want to draw this as the front view, I could look at it this way and I could trace. I'm just very roughly tracing what I think I would see. I would trace the object shape like that. Let's just put some detail in, and it's got those two there. Alright, so I've got little screw holes, so I've just drawn it very roughly. Alright, so I'm looking from the top, and I have now seen whatever I see on the top, I'm drawing below, and I drew that as my front view. Now if I look at this from the top of my drawing, so this would be front. If I wanted to draw the top view, I would look at it from this side. So essentially we move it down here and we flip it up. So now we're looking at the top view. So what do we see on the top view? Kind of tapers in like that. And then it's got this latch mechanism, something like that. Alright, so you can see there's the front view, is whatever we're seeing we draw behind. Top view, whatever we see we draw behind. And then the side view, okay, let's draw this side because I'm running out of space there. We would take it, flip it up this way, whatever we're seeing there, looking at this way, and we will draw it on this side. And there's our mounting, there's the clip, and there's the button. Alright, so there's the front view, there's the top view, there's the side view. So you can see this would be the right, that's front, and that is top. So these three views are first angle projection. Now to illustrate third angle projection, I've got a sheet of plastic here, of transparent plastic. So essentially what you'd be doing is looking at your object through a plane and drawing what you see. Alright, so if I trace what I'm seeing here, it's got some kind of a clip thingy, and there is the mounting at the bottom. Right, so there is my third angle. So this would be front. If I want to draw the top, then I must hold it like this. Just hold it like that. Let's see if I can just balance it. Well, a bit awkward. And I would draw the top view like this. Alright, so you can see there's my front view, there's my top view, and then my side view. If I want that view, I would have to do that. Alright, so you get the idea. So the reason I'm holding this piece of plastic in front of it is to show you that your plane that you're going to draw on is in front of the object that you're looking at. So you're tracing essentially what you see in those three views. So that would be top, and that would be the right view. Alright, hopefully that makes sense to you. So this would be third angle. Projection. Probably can't read that, but anyway. So in first angle projection, we are taking the object and we are drawing on the other side, so we just flip it up. We do it like that. We draw what we see. But in third angle projection, we're flipping it up we're drawing what we see in front of the object. We're flipping it up like that and like that. All right, so essentially if we compare these two drawings, what do we notice? The pictures are the same. So that picture is the same, and that one is the same. the front view. All the views are exactly the same lines in exactly the same place. The only difference is the position. The right view moves from the left to the right. The top view moves from the top to the bottom, from third to first angle. Hopefully that explains things a little bit more clearly. So now that you know the basics of the difference between first and third angle projection, I thought I would do a drawing for you just to take you through the process of doing an actual drawing. And let's start off with a first angle projection example. I'm not going to draw this example because the construction technique is shown here. So you need to go through this example and actually draw it for yourself according to the instructions that are given. And here's the final result, so you can check whether you are doing it correctly. So here we can see our symbol. We're looking from the left, we draw on the right, so that is first angle projection. That's what they asked us to do there. So what I'll do is draw one of the exercises, which is this one here. So it asks us, it tells us two views of a machine casing are shown below. We must draw 1-to-1 scale, so whatever we see here, so that's 150 millimeters. We actually have to measure 150 millimeters, and this is a little short. So we have to measure that and draw it the exact same size. In first angle orthographic projection, what is this symbol? This symbol is third angle. So they've given us a third angle projection drawing, and they've asked us to redraw it in first angle projection. But you've got to do the following views. First of all, the front view as shown. So copy what you see here. Here's your front view. A sectional top view, the section being taken on the cutting plane BB. So here is BB. So the top view in first angle projection, we'll draw that top view, looking at it from the top, drawing it underneath, and only drawing what we see below the line, nothing above the line. So we're deleting everything above the line, drawing what we see below the line. Thirdly, a sectional elevation taking on a cutting plane AA, looking in the direction of the arrows. So here's AA. So now we're looking in this direction, which is a left view. We're drawing it on the right hand side. So we delete all of that and we draw what we see over there. Just remember, if you do get stuck with your examples, they do give you the answers, a little small view of what the answer would look like for each of the questions, so you can actually check yourself, see if you're doing it correctly. All right, so let's get busy with this example, this exercise. I've got to take this paper off. And let's draw on this one. All right. The first thing that we do when we start a drawing is we need to plan the layout. In fact, before that, we probably should do some borders. I'm just going to draw them roughly here. About 1 centimeter all the way around. There's our page border, and you can do a title block as well. So we should probably measure these off. Let's just make them 3 rows. I'm making this 1 centimeter just for interest's sake. Let's make it 100. That should do the trick. my drawing board's ruler is a bit wonky, so it's not going to draw it exactly perfect. But there you go. Alright, so this is first angle projection. I wouldn't have fitted orthographic in there. And this is question 1, and then your name at the bottom. And then your student number you would put over there. All right, so just make sure all your drawings have a title, have your name and your student number on it as a minimum, so that I can recognize who it is. And then also remember to put your student card on the page when you take your photo, and then convert it to PDF using the app that I've told you about. Right, coming back to the drawing, we have to plan our views. So we know that it's orthographic projection, that they've asked us to do first angle, and they've asked for a front view, a top view, and a left view. So that's front, bottom, and it'll be on the bottom and it'll be on the right. So what is the height of this thing? It's 150. Let's just get my scale ruler going here. It's 150. So if I position it, so there's 150 from there to there. Is this enough room to draw a top view? That would be 100. Okay, it's very, very tight. So I might have to move it up slightly. Okay, let's take it right to the edge. We go 150. And then you see 100 would be there. All right, so now we know we can put our top view, we can fit it in. Our front view we can fit in as well, that is the height of it. And then our left view, which is also a sectional view, is 140 millimeters. So let's see, that's 140 to there. That's the left view, and 140, actually that's 100, it's not 140. This would be 100. The left view would be 100 because it's the same as this, taken up in that direction, and then 140. So we can sort of lay that out like this. All right, so the front view is going to be between here and there and go across to there. Top view is going to be like that, the same width, and then the left-hand side view on the right is going to be that size and that height. So I've planned the layout of my drawing. I can see where everything is going to go. Right, so I can just draw some construction lines. In fact, those lines will go right across both views. This one will only be on this side. I think it's there. Just fits on the page nicely. And we take our set square. Let's start drawing our vertical lines. I need a bigger set square. It's a little short. This one there, and then this one. So transferring these lines down to the bottom. Right, so now we have the box, a box for each of the views. Front view, top view, and left view. Right, so let's start with the front view and draw that detail. And they ask us to draw it the same as we see in this view. Right, so let me transfer this information. Just leave it off camera here. And the base is 16 millimeters thick. I'll make a mark. So remember the base is going to be in the side view as well, so we can transfer that across. What else have we got? 50 and 38. 50 to there, and that gap is 38 millimeters. More stable if you lock these rulers in position. All right, now we have a 44 millimeter wide pillar coming down here. 44. So out there. Okay. What would we do next? Let's do the back. 3 millimeters down from the top. 3 will be there. 1, 2, 3 there. All right, now they tell us we have a radius of 65 and we have a line that's going up at an angle. But we don't know what that angle is. So we have to construct this radius. So let's set our compass to that radius of 65, like that. And now we know that from this point, the center point of that radius I'm going to draw like that is going to be 65 millimeters from that 3 millimeter point there, that's further down on this line. Okay. We also can see that the center line is actually on that line. The center is actually on this line that's going down here. So that makes life easy for us. So I've marked out my 65 distance, and I can then draw my arc. And from this point, we have to now draw our arc upwards, our line upwards, tangent to that circle there. Okay. Take away some of the arc. All right. Now we can work on this circular section over here. We've drawn that 65 arc and that line. So we can work on this here. So we see we've got a 21 radius going through. That cut line is in the middle. But we can see that the gap here is 38 and it would be 42 if that was in line with there. So it's actually further up. Okay, but we do have the upper and the lower points. So if we set our compass to a radius of 21, there's 21, and we measure from the top point downwards. That is the center of our 42 circle. So we can now draw this arc. Make sure you draw it nice and dark because it's an outline. Try and keep your lines consistent. So my line there is a little darker. Anyway, so I can now draw all these little radii. I'm not going to draw all the radii in at this stage because I don't have a radius stencil. Okay, so that goes there, and that goes to there. And here's your vertical line. No, that's a mistake. This line is not here actually. That's on the top. All right. So this line does come down, but not the whole way. So there's another radius here, which is 10 millimeters more than the 21, so that would be 31. Set our compass to 31, place it on the same center point, and then draw our arc all the way around. Join that point up there. All right, so I've got some of this structure, I've got that arc, that circular section in there. This is also 10 millimeters on the front. So what I would have is a horizontal line across there and go down. The base goes all the way across. Yeah, so it wouldn't go the whole way. Getting confused with my lines. So this is the base. And it goes up to there. And across again. And down here. So this is actually construction. If the construction lines are light enough, you don't have to erase them. Alright, I just took some of that arc away there. Okay. So I've got this outline all done. There's the base, that arc goes around to the top, and this one then goes across to the center, and then it's got a radius. Okay. Normally you draw all your radii in afterwards. Right, so we have a center line 22, 44. So this is 44, this width. So 22 is the center. So we can actually draw a center line. Now that's useful because there's a hole 28 millimeters from the bottom, somewhere around there. 28 is there. So that is the center of the hole. You can actually just draw the center line in of the hole, and that hole is a diameter of 13, 6.5 millimeter radius. If you've got a circle stencil, it's a lot easier. I don't have one at the moment, so drawing such small circles is really difficult. 6.5. And you have to be careful. I'll try and get it neat. There it is. And they've asked us to put hidden detail on this drawing as well. So that would mean we would need 10 millimeters, a hidden line going through the top, 10 millimeters away on both sides. So goes right through to the bottom. There's a hidden line. and we also have 2 screw holes, and they are 20 millimeters. Yeah, in the top view we can see there that dimension of 20 millimeters and 20 millimeters from that point there. So this is where our hole centers are. We can actually draw our center line. We have a diameter 8 hole, and we can see that on the top view. So I can just measure that, 4 and 4. There's 4 millimeters, 8 millimeters. And these are hidden lines as well. Not right to the top, because we have a countersink on the holes. So now it's a 16. Sure. The measurement doesn't look quite right. Let's use this ruler for my measurements. 4 and there's 8. Something was a little bit off there. I'll have to redo those lines. Alright, so there's 5, there's 4. Let's use my trusty old ruler. It's been with me for years. There we go. That looks more accurate. That's 16, so that will be 8. So I'm measuring the size of the hole at the top. So that is 8, 16. And then it's a 45 degree chamfer. Doesn't look like I have a 45 degree set square. Alright. Unfortunately, I don't have a 45 degree set square now, so I'll have to just guess it. Right, so there is our front view. Now we have to construct the top view. So I'll put a label here. So this is the top view. And we can transfer a lot of the information downwards. Right, I can't use the ruler because it's too close to the edge. So I can transfer with construction lines some of the information from the top here. So there's the center line. Yeah, so these lines will also be there. Now this is a symmetrical object and it's 100, so we need to find the center line horizontally. That's 50. So let me just draw that center line, save time. Now we can start drawing some of the circles. All these circles on this top view though. If we look at it, the circular section is all on the top here and those holes stop there, so there's actually no circular section. So let's draw the base shape first of all. We have a 50 millimeters distance, so I'm going to pick the right scale, which is 1 to 1, and we've got to measure 50 and it's 50 millimeters over here, so that would be 25 in the middle and 50. So now I can just join those two. It's an outline, so I'm going to do it nice and dark. The same on this side. It helps to put your pencil down on the one point and then just pivot the ruler to the other point. Then you want only one to line up and not two. Alright, so those radii, there's a radius of 6 millimeters on these corners. And I can't really draw a radius. Oh, I've just found a few radius on my ruler. So there's a diameter of 6. If we measure it, we can check. Yes, diameter of 6. Radius of 6 would be actually 12. Alright, so I could use this as a template, line it up and do the corners. Diameter 12, radius 6. So you can see, I can see the two lines. I just draw my little radius. And on this side, should probably just take it back a little. Now that's pretty useful. Hopefully your rulers also have these circles on them. So that whole base we can see on the top view when we cut it. So we need to draw the cutting line as well, cutting plane, which actually goes through there. We can make it slightly thicker at the ends. And then put our arrows in. So that just reminds us that we're deleting everything on the top of the front view and we're showing everything below it. So we've drawn the base. We can draw those holes. We said they are 20 millimeters from the end. So we can just quickly construct the centers. They are 38 millimeters apart. There's 19. That ruler I'm not going to use for measuring anymore. The other hole is 13 millimeters from the end. So that's 10, 13. And the distance is 20 back from there. So we can just transfer it straight down. That should be in line there. Right, so now we can actually use the circle stencil to draw our 4 millimeter or 8 diameter holes and the 16. So we line those up on the centers. Draw the 8. And then 16. It's the biggest one I have. As long as you're lining up with the center of the hole, the circle will be concentric. Those are the holes. Now we've got a 56 millimeter base. So that would be 28 millimeters in each direction. Yeah, so that goes up to this line here. So we actually got that line in already. The next thing is to draw that web in the center, which will be 13 millimeters. Six and a half. So that's 6.5. $13. to there. So, looking at our cutaway, we'll definitely see that this as a sharp edge. So we can start drawing in some of that detail. However, there is some of this web that is going to be cut away as well. Some of that web, you can see that web that comes out sideways, that's also going to be cut away. So what is the width of that web? It's the same width as this. So we would end up with a cutaway piece that is almost a T shape. And this line, in fact, won't be a solid line. Because this is going to continue up to that edge. And in fact, yeah, I've got to take it away because this is actually a construction line. All right, now the question is, if we're going to cut through this section here, we put a hatchet. So do those diagonal lines. Where is that point visible on here? So we can construct it by taking it down. We take that point and we mark it off down the bottom. We know that point is there and that point. All right, so we've got the sectioned part of the material. We can draw it here. And now I'm going to do my hatching, but I'm going to do it with my 30-degree set square instead of my 45 because I can't find the 45-degree set square. So let's just do some hatching in here. In fact, yeah, that's way too dark. Just needs to be light but consistent lines. Be careful, you only hatch the portion of the material that's been cut by the sectioning plane, which is BB in this case. Keep your hatching lines nice and consistent. Alright, so there you can see the part that's been cut through. There's air here and it's cut through the material there, which is in the shape of a T. Alright. So what other detail do we still need to add? There's a few bits of hidden detail. Let's just draw our hidden lines here, which actually just go up to that line. They asked us to do hidden detail. Sometimes you leave hidden detail off a sectional view, but in this case they've asked us to put it in. All right. So the only thing left to do is hidden detail in this area. So what we have here is a 20 millimeter. So that is 32. If we look at our front view, we can see that we have hidden information over here. That is 32, so that would be 16 to the center. It doesn't come all the way to the front. It's in line with this. So it's essentially this section in the middle that we're drawing now. Already on top, so I can transfer that line downwards. Right, so now we have a hole that's going through here. So that hole is cutting through this center portion. So we can transfer the sides of this hole onto our drawing from there. Show the hidden detail. All right. So that is basically our sectional top view, which is actually called section BB. I can take some of this construction line away if we would like to. Clean up our drawing a little. Not really necessary to erase all your construction lines, but it depends if you want your drawing to pop on the page a little bit better. All right, so the last view we have to construct now is section AA. Now where does that go through? Section AA is actually right through the center here. We've already got a center line. So we can just write our section, just make it a little bit thicker on the ends. Section A. So we're looking in this direction and we've got to draw it there because we have our orthographic projection, which is first angle. So what I haven't drawn here is the symbol. I'm just double checking the size that I asked you to do it. So it's 12 and 6. So we draw 12. And we draw 6. You always need the symbol on your page. center line's a little long. There you go. So this is an interesting one because we have to transfer the dimensions across and we don't have anything given in the view. So we have to do a bit of construction ourselves. So we know the base is the same width as that. We've already put that on there. What else can we transfer? So we're looking at it from this side, so we won't see the back. We're also cutting it here, so we will see the center portion. So let's figure out where the center line is and start constructing from there. Alright, so here's our center. That's the center line. Alright, so there's a few things we have to construct here. We need to know the width of that upper section, and then we need to know the width of this section. So this width, that width, and then this section's width. So the upper section, we can see that that is a diameter so that's 44, pretty cool. So we can draw 22. So everything going up to that line is that width. Right to the top. We've also cut through the hole, so therefore they will be hatching on either side, and there'll be a hole through the middle, and they've told us the hole diameter is 22, so that would be 11, 10, 11, 22. I can construct, we can draw the inside edge of the hole. This one goes right through. Actually, yeah, that line is not really useful to us. At this point. We've got the base, and the base has some holes in it for those screws. But the most of the base is its full size. All right. So in the center, we've now got this portion here, which we can transfer across. We've got the one line. We just take the second one across there. Now what width is it? Well, you can see that from this view, it's that width. And that would be 56, which should be 28, half of it. Okay, now there's a part in the middle, and that is wider, in fact, or narrower, should I say. That's this section here we have to transfer, and that is 32, so that's 16. In fact, these two lines shouldn't be there because the material is continuous. So as we cut it through there, this is one piece of material. So actually we won't have a line on the top and on the bottom. So what we do have is a hole that goes all the way through. So we can transfer that line for the hole. So that is, tore my paper a little bit. That is actually slightly below the line there. Right, so now this section is all been cut, so therefore we have to do hatching. So let's get that organized. Okay. Start on this side. Draw some hatching through all the material that has been cut. And if it's one piece, then all the hatching will go in the same direction. If it's an assembly and you're doing hatching, different parts in the assembly will have different hatch patterns or directions. Actually, the top also needs hatching. Same materials, same hatch pattern, same direction, and same spacing. Right, we've got a section in the middle here where we need to connect it up, and it looks to me like it's the same width. So that would be this part here. going around. And according to this view, the width of this is the same as the front. So I can essentially transfer this line further down. All right. So this is section AA. What I forgot to do is draw in my screw holes, and those are 13mm from the end. So that's the center lines. I have to just take some of the hatching away. And those holes are 8. With a 16 chamfer. Chamfer that goes from 16 top. Yeah, so we're cutting through the screw holes with our cutting plane. Because they're right in line with this. So that's why they are actually hatched. So this should be 45 degrees. I don't have a 45-degree set square right now, so I'm just constructing it by hand. All right, just put in the lines we rubbed away. And that would be our first angle projection question 1 view. So when you finished your drawing, just make sure that you've put in center lines. So the center lines on those holes, there's a center line through this because it's symmetrical. Center line through there, the center line through those holes. Center line, 2 cutting planes. I should probably just add some better quality center lines on these holes. Your center line should be lighter and not as bold as your outlines. Alright, so I've got center lines and everything. I've got my title block. I've got labels on all the views. They could be neater though. And I have my projection symbol. Alright, that's all we're going to do for this video.